everyone. My name is Madhuri Gupta, working as an assistant professor in the Department of Computer Science, Chhattisgarh Swami Vivekanand Technical University, Bhilai. Welcome to this introduction to the world of artificial intelligence. In this video, we will take you on a journey through the fundamentals, applications and future prospect of AI. What is artificial intelligence? Artificial intelligence or AI is the science and technology of creating machines that can perform tasks that would typically require human intelligence. These machines are designed to perceive, reason, learn and act, empowering them to tackle complex problems in innovative ways. AI encompasses various exciting areas, each with its unique focus as shown in the figure. From machine learning, where machines learn from data and experience, to natural language processing, enabling computers to understand human speech and text, and computer vision, which allows machine to interpret and analyze visual information. AI algorithms processes vast amount of data, enabling machine to recognize patterns, make predictions and even create art and music. These capabilities have transformed numerous industries from healthcare and finance to transportation and entertainment. AI has also brought us humanoid robotics that can assist with tasks and interact with humans, and autonomous vehicles that navigate the roads without human interventions, making transportation safer and more efficient. We interact with artificial intelligence in our daily lives through virtual assistants like Siri and Alexa, who answer our questions and help with tasks. Artificial intelligence powered recommendation systems personalize our online experience, suggesting movies, product and news articles tailored to our performance. How artificial intelligence and machine works. Here in this diagram you can see we categorize the human and machine working in the 4 categories: system that thinks like human, system that think rationally, system that act like human and system that can act rationally. So, system that act like human, like Turing test, the art of creating machines that perform functions that requires intelligence when performed by people. This definition is given by Kurzweil, and the study of how to make computers to do things at which at the moment people are better. This definition is given by Rich and Knight. You enter a room which has a computer terminal and you have a fixed period of time to type what you want into the terminal and study the replies. At the other end of this line is either a human being or a computer system. If it is a computer system and at the end of the period of time you cannot reliably determine whether it is a system or a human, then the system is deemed to be intelligent. So, system that act like humans, that means Turing test approach, where a human questions can tell if there is a computer or a human answering his questions via teletype. The computer must believe intelligently, intelligent behavior to achieve human level performance in all cognitive tasks. System that can act like humans, these cognitive tasks include natural language processing, knowledge representation, automated reasoning and machine learning. So, again we come to this diagram where we can now come to the system that can think like human. System that can think like humans, that means cognitive modeling. Human as observed from inside. How do we know how human thinks? Cognitive science, the exciting new effort to make computers think, machine with minds in the full and literal sense. The automation of activities that we associate with human thinking activities such as decision making, problem solving, learning, etc. So, now come to the approach where system that think rationally. So, we have law of thought. Humans are not always rational. Rational means defined in terms of logic. Logic can't express everything, that is uncertainty. Logical approach is often not feasible in terms of computation time. The study of mental facilities through the use of computational models. The study of the computations that make it possible to perceive, reason and act. Now, we can now learn systems that act rationally. Logic only part of a rational agent, not all of rationality. Sometimes logic cannot reason a correct conclusion. At that time, some specific human knowledge or information is used. Thus, it covers more generally different situation of problems, compensate the incorrectly reasoned conclusion. Study AI as rational agent. So, here are the two advantages. It is more general than using logic only because logic plus domain knowledge is more efficient. It allows extension of the approach with more scientific methodologies. So, rational agent. So, what is agent? An agent is an entity that perceives an act. The course is about designing rational agent. Abstractly, an agent is a function that perceives histories to actions. Here in this we have one formula which describes function from P to A. Human as observed from inside. How do we know how human think? Irrospection versus psychological experiment. Cognitive science, the exciting new effort to make computers think machine with minds in the full and literal sense. The automation of activities that we associate with human thinking, activity such as decision making, problem solving and learning. So, what is the goal of AI? To make computers more useful by letting them take over dangerous or tedious tasks from human. Understand principle of human intelligence. The foundation of AI philosophy. At that time, the study of human intelligence began with no formal expression, initiate the idea of mind as a machine and its internal operations. Mathematics. Mathematics formalizes the three main areas of AI: computation, logic and probability. Computations leads to analyze the problems that can be computed, that is complexity theory. Probability contributes the degree of belief to handle uncertainty in AI. Decision theory combines probability theory and utility theories. Psychology. How do humans think and act? The study of human reasoning and acting provides reasoning models for AI. Strengthen the ideas human and others animals can be considered as information processing machines. Computer engineering. How to build an efficient computers, provide the artifact that make AI application possible. The power of computer makes computation of large and difficult problem more easily. AI has also contributed its own work to computer science, including time sharing, the linked list, data type, linguistics. For understanding natural language, different approaches has been adopted from linguistic work, formal language, syntactic and semantic analysis, knowledge representation. The main topic in AI. Artificial intelligence can be considered under a number of headings: search, which includes game playing, representing knowledge and reasoning with it, planning, learning, natural language processing and expert systems. Some advantages of artificial intelligence. more powerful and more useful computers, new and improved interfaces, solving new problems, better handling of information, relieves information overload, conversion of information into knowledge. The disadvantage: increased cost, difficulty with software development, slow and expensive, few experienced programmers, few practical products have reached the market yet. Search is the fundamental techniques of AI. Possible answers, decisions or courses of actions are structured into abstract space which we then search. Search is either blind or uninformed. Blind search, in which we move through the space without worrying about what is coming next, but recognizing the answer if we see it. Informed: we guess what is ahead and use the informations to decide whether to look next. We may want to search for the first answer that satisfies our goal, or we may want to keep searching until we find the best answer. Knowledge representation and reasoning. The second most important concept in artificial intelligence. If we are going to act rationally in our environment, then we must have some way of describing that environment and drawing interfaces from that representation. How do we describe what we know about the world? How we describe it consciously? How do we describe it so that we can get hold of the right piece of knowledge when we need it? How do we generate new pieces of knowledge? How do we deal with uncertain knowledge? So, in this diagram we have knowledge as declarative and procedural. Declarative knowledge deals with finite questions like what is the capital of India. Procedural knowledge deals with how. Procedural knowledge can be embedded in declarative knowledge. Planning: given a set of goals, construct a sequence of actions that achieve these goals. Often very large search space, but most part of the world are independent of most other parts. Often start with goals and connect them to the actions. No necessary connections between order of planning and order of execution. What happens if the world changes as we execute the plan and or our action does not produce the expected result? Learning: if a system is going to act truly appropriately, then it must be able to change its action in the light of experience. How do we generate new fact from old? How do we generate new concept? How do we learn to distinguish different situations in new environments? Interacting with the environment. In order to enable intelligent behavior, we will have to interact with our environment. Properly, intelligent systems may be expected to accept sensory input like vision, sound, interact with humans, understand language, recognize speech, generate text, speech and graphics, modify the environment with using robotics. History of AI. AI has a long history. Ancient Greece like Aristotle, as old as electric computers themselves. Historical figures contributed: Raman Lull, AI Novarajmi, Leonardo da Vinci, David Hume, George Boole, Charles Babbage, John von Neumann. The von Neumann architecture. In this diagram, you can understand how Von Neumann architectures is related to the artificial intelligence behavior. History of AI. Here are the origins where the history of AI begins. The Dartmouth Conference in 1956, John Marathi, Herbert Simon, Alan Newell and Arthur Seymour. The Turing test in the year 1950. Machine Who Think by Pamela McCordley. The periods in AI. Early periods, that is 1950s and 60s, game playing, brute force, theorem proving, symbol manipulations, biological models, neural nets. Symbolic application periods, that is 1970s, early period systems, use of knowledge. Commercial period, that is 1980s, born in knowledge rule basis. Periods in 90s and new millennium. Real world applications, modeling, better evidence, use of theory. Topics like data mining, formal models, fuzzy logic, agents, neural nets, autonomous systems. Applications, visual recognitions of traffic, medical diagnosis, directory, inquiries, power plant control, automatic cars. Fashions in AI. Progress goes in stages following funding booms and crises. Some examples. First, machine translation of language. 1950s to 1966, synthetic translators. 1966, all US funding cancelled. 1980, commercial translators available. Second, neural networks. 1943, first AI work by McClubbs and Pitts. 1950s and 60s, Minsky book on perceptions stops nearly all work on nets. 1986, rediscovery of solutions leads to massive growth in neural nets research. The UK had its own funding freeze in 1973 when the Lighthall report reduced AI work severely. Lesson: don't claim too much for your discipline. Look for similar stop and go efforts in the field like generic algorithms and evolutionary computing. This is very active modern area dating back to the work of Friedrich in 1958. Here we have different AI applications: autonomous planning, autonomous rovers. AI applications: autonomous planning and scheduling, telescope scheduling. Autonomous planning and scheduling, analysis of data. Medicine, image guided surgery. In medicine, image analysis and enhancement. In transportation, autonomous vehicle control. In transportation, pedestrian detection. Games, games like chess, robotics toys. Other application areas: bioinformatics, text classification, document sorting like web pages, emails, articles in the news, video image classification, music compositions, picture drawing, natural language processing. So, check your understanding. So, here we have one question for you: what is the ultimate goal of artificial intelligence? So, here we have four options. Option A, to simulate human intelligence. Option B, to replace human intelligence. Option C, to enhance human intelligence, and option D, all of the above. So, here is the right answer, that is option number C. So, here are we have takeaway, key takeaways. At the end of this chapter, you are now able to explain the importance of AI, explain how AI works in different areas, discussed the advantage and limitation of AI systems, explored the history of artificial intelligence. Thank you.